Good morning, everyone in the room and in wherever you are today joining us for this early morning math session. We're happy you're here. If you can hear us in the virtual world, please make sure that you type into the Whova chat that you can hear us so we know you're there. Yeah?
Whenever you're ready to share your screen, go ahead. We'll check that too.
Oh, yes. Let's do that.
And they can hear you fine.
All right, and now you should be able to see my screen, those of you in the virtual room.
Yes.
Oh, thank you. Love it when 8 a.m. sessions work out that way. Thank you so much. Welcome. For those of you that are in the room, they've been working on a little bit of a tanagram puzzle just to get us started before the time. Don't worry, you didn't miss out on too much. They are getting their minds ready and into math, but we are going to go ahead and get started. I'm going to introduce myself in a little bit. I wanted to first take a minute. We're going to do a little prayer to the tech gods and say, let's hope that this video everyone can hear it, because that's our first part. That's our first piece today. I want to show you a little bit of video. This man's name is Robert Kaplinski. He is a K-12 math educator, connoisseur, if you will, one of the greats, if you will, in math education. And I wanted to introduce you to the concept of productive struggle, if you have not yet explored that. Hang on. That's too low, right? We're working on the volume. Sorry. I know that's annoying. I'm working on it.
With closed captions, it might be loud enough.
Yeah, I'm not finding that control. That's part of my...
You can hear it.
We're going to go this way. One moment for our 8 a.m. session and our virtual participants and our in-room participants. All right, this video, he talks very fast. He's from California, which I don't think of them as being fast talkers, but no offense to any California people, but he talks very fast in this video, so I am going to turn on closed captioning so you can kind of watch. And you don't always see his mouth. You are watching other images. So as we watch that, keep that in mind. They probably can't see that, right, Anita?
Correct.
Can you look up in YouTube, Productive Struggle, Robert Kaplinski, share the link with them in the chat. Thank you. For those who are in the virtual world, we're going to put a link in the Whova chat for you to watch this video on your own, as it's becoming hard for me to be able to play the audio in the video, but I still want you to be able to watch the video. So in just a moment, Anita's going to go ahead and put the link in the chat to the video we're going to watch in the live room, and then we'll all come back together and talk a little bit about it.
Is it 5 minutes?
Yep.
Great.
Where is my YouTube?
Now you can eat with a TurboTax X
Now we have to watch an ad. This is as loud as it's going to get. I encourage you to watch the captions. I've turned the volume up on everything so far, so. I am going to go back to the beginning, however. All right, so I know that that was a little bit hard to hear in here in the room. I appreciate your patience, and I appreciate your patience with my tech things. It's a pretty difficult job doing a hybrid presentation, and so when you've got lots of moving parts, we're keeping it together though here at 8 a.m. To my virtual participants, I hope you were able to watch at least a piece of that. I think that this video illustrates really carefully what productive struggle is, and also allows us to think about, while it's in the setting of K-12, right, allows us to think about how we could create productive struggle opportunities for our students. For those people in the room, I gave you some tangrams on your table and asked you to try and make a square out of those tangrams. Do you see any connections between productive struggle and the tangram activity? Yes? I see this table nodding. Does anyone want to share?
It's like you think you see it, but you really don't. Like you think you're seeing it at the moment, and then you're getting in there, and then it's like, oh, that doesn't fit. So then now you're struggling because you're like, but I just saw it. Why can't it fit in there?
So you're in that feedback cycle, like Robert Kaplinski was talking about, right? That idea of I see it in my mind. I think I can do this. Get there. Oh, okay. But that one can't be right now, right? So now I need to change that piece. Any other comments about your productive struggle experience?
At first, the problem seems almost impossible once you start putting the pieces together and you're like, oh, this doesn't work. It's not as easy as I thought. But the productivity comes in when your brain starts making smaller pieces. Instead of trying to find the whole square, I tried to like copy half and half. So my brain started to break it down a little smaller. And then I was able to make progress. So
and
that's
what's
productive.
your name?
Michelle.
Michelle, I feel like you've just set my presentation on a great trajectory here, because what Michelle said that we're going to explore more is not only productive struggle throughout today. I'm going to give you some opportunities to productively struggle, but then also this idea that sometimes our brain needs to take things in small bites in order to make sense of them. And our students don't always see that either in the math education classroom. They don't always see that, not just that there's steps, but that even in word problems, which is why we're here today, we're here for going from puzzled to proficient. There we go. Students tackling math word problems. Notice it says students tackling math word problems, not teachers tackling math word problems. That's intentional. Your students are the ones who should be tackling them with your facilitation and guidance and support. And that's what we're going to talk about today. My name is Amber Fornaciari. I work for the state of Illinois, and I am a professional development specialist in that state. I also am an adult educator. Well, until recently. I moved to Ohio in the fall, and so I work for the Professional Development Network in Illinois, but live in Ohio, and I have been an adult educator until this fall, and so I'll get back into that after my family's settled in Ohio. I have a math education background, but I have taught, actually, I just realized recently that I have taught longer in adult ed than I ever did in the K-12 system now, and so that makes me feel very, very old, number one. Number two, that I feel like I'm in the right place. So those of you who have, those of you in the room, you should have a handout. It has some like colored boxes on it. That is a notes document for you to kind of follow along throughout today. You can feel free to use that however you want. That is not necessarily a resource for you to take away. These are my notes from this session. This resource doc will also be in the Whova app. So if you are online, I don't believe it's there now, but if you are online, you will be able to access this too. For the purposes of today, since this is a hybrid session, those of you who are online with us in the virtual world, we want you to be very active in the chat as we do these activities. Please follow along and I'll prompt you as well. But we're going to do our best to pass the mic and make sure that all questions are on mic so that everyone can benefit from them as we move forward today. I am also an active member of the Adult Numeracy Network. Raise your hand if you are a member of the Adult Numeracy Network. Oh, I got a whole room. How many of them are there, Anita? Okay. All right. So you are actually in the adult numeracy, one of the adult numeracy network's 2 rooms that we host at the conference. We are the strand partner for the adult numeracy network. And so you can see there's maybe this table has a few more things on it than some of the other rooms you've been in so far. That's because we are here to learn about math. And we know that math is not just done on paper and pencil, and it's not just done on the computer. You can feel free to use any of the materials in the middle of your table today to help you with the tasks that we do. It is not required by any means, but the Adult Numeracy Network is a network of those of us that teach numeracy within the adult educator world. We highly recommend that you join the Adult Numeracy Network, and there is some information in the center of your table about how to do that. There's a stand-up placard, and then there's a few other pieces of paper there explaining what the Adult Numeracy Network is. We are a volunteer-based organization bringing math adult educators together across the country. So that's my spiel about the Adult Numeracy Network. All right, here's our agenda for the rest of this session. We're going to talk briefly about what numeracy is. Some people have numeracy and mathematics in the same bucket in their mind, and while they are definitely related, I want to make sure we have a strong definition of numeracy. Well, we're also going to have a discussion about asset-based language and what that looks like in the math classroom. We're going to practice asset-based language with a productive struggle task. We're going to have a discussion about word problems, and then we're going to dive into what I call the 3 reads, well, not what I call, what the founders or the makers of the 3 reads protocol call the 3 reads protocol, which is a strategy to support and scaffold math word problems for our students. Raise your hand or put it in the chat if you have ever heard the phrase that's on the screen or something like it. All right, do it all at once now so I can tell how many of you, if you have heard something. I think we're at 100%. Yeah, either I can't do math word problems, I don't like word problems, I hate word problems, don't make me do word problems, right? It goes on and on and on. I want these statements for our students are not them trying to push back and say, are not necessarily them trying to push back and be defiant or disrespectful in some way to our profession, right? And I hope you can see that. These statements come from a place of avoidance, from a place of fear, previous influences, and a lack of numeracy, not necessarily math instruction. I'm going to get into that in a second. In the room, or in the chat, did they raise their hand? Oh, yeah, okay. Thank you guys for being really active there. Can you think of a way that you used math within the last 2 days of getting here? Getting here, coming to this conference, this morning, take about 15 seconds. Think about a way that you used math in the last 2 days. And then talk to someone at your table if you're in the room. Just tell them what you were thinking about how you used math. And then make sure you listen to your partner. If you're in the virtual world, please tell us in the chat how you used math in the last 2 days. Make sure your partner has had a chance to tell you their mathematics. All right, put a period on your sentence and let's come back together. Quick poll, if you will. How many of you shared something about your travel, the way that you got to COABE, or whatever that was? Okay. How many of you shared something about setting your alarm clock? All right, to make sure you were on time for this 8 a.m. session, right? How many of you shared something about your schedule, your calendar, your bank account, something on your phone maybe? Okay. Others that you want to share? I'll repeat them to for the virtual people. Yes.
Figuring tip.
Figuring tip. Oh, yes. Yes.
Direction I went on the hallway from my room.
Oh, yeah. Because you saw the numbers? Yeah, because it's a range. Yeah, someone shared that when they came out of their hotel room, they had to know which way to go, and they looked at the signs that said, room 2 through, or 302 and to 3010 or whatever it was, right? So these are all ways that we are using math, and we are becoming numerate adults. Numeracy is what we do with mathematics. So there's on your note sheet, if you're like, oh, there's a little closed sentence there. Yeah, that's what this is for. Numeracy is what we do with mathematics. Numeracy extends mathematical knowledge by acknowledging its context, the tools that are used, and the dispositions of learners. Mathematics embedded in context that often involves more than one person. These are not my words. This is Dr. Kiko Yakasawa from the University of Technology in Sydney. And on my slides, which you will have access to in the Whova app after my session, there are live links. And at the bottom, there is her YouTube playlist. And she has a series of about 6 YouTube videos. They are all within 5 to 10 minutes each, explaining numeracy in adult education. And I wish I probably should have submitted a session just on that, and we watched all those videos. But I feel like that's something you can watch in your own time and kind of take bites out of in order to comprehend what exactly is numeracy and what does that look like in an adult education classroom. We're going to practice it. You guys have already showed me how your numeracy skills, and I kind of overheard them at the tables as you were talking. Anita, was there anything in the chat that we wanted to share?
On board, distance and time, driving from home, calculating tax on a group bill at dinner.
Yes.
So a lot of same.
When the ANN group, one of the things we do when we come together, because we're from all over the country, when we come together at this conference, we usually have a dinner together. And it was funny, this time the restaurant that we went to would not give individual bills. They would only give one. And there was a group of, I think, 10-ish of us. And there was a gratuity, and there was then tax. And we're sitting there as numerate people figuring out from this one bill how my items, then how much that is for tax, how much that is the gratuity, and then, okay, now how do I pay who, right? Go ahead, Janae. Oh, yes. We didn't. Yes. One of my colleagues just reminded me, we didn't know what the tax rate was. And so us being very detail-oriented with numbers, right, we were like, we need to know, is this 8% or 10%? And there's people shouting across the table, I think it's 8% based on my calculations. No, I think it's 10. I know Indiana. So, I mean, many of you said things about tip, right? Calculating tip, or even just calculating your bill when you're in a group, especially with colleagues, right? We're not expecting anybody to pay for all of us. These are all parts of numeracy, and I will tell you that sometimes, I want you to also be mindful of this. Some of the things that I do and the ways I use numbers in my life has not even occurred to my students to use in their life. And what I mean by that is, if I had given them that problem of there's 10 people at this table, this is the gratuity, this is the tax, they likely would have said, we're just going to divide by 10, and everybody, because they don't have the skills yet to go ahead and think about what is that tax and what does that mean to the bill and those relationships between the numbers. And how do I calculate the tax and the gratuity, and then add that to just my bill, not it divided by 10, right? So just some thoughts. I want you to kind of open your mind to how you use math. Might not all be the way that your students are using math in their daily lives. So it's a good idea to also get their opinion about how they are numerate. All right, a little bit about asset-based language. 2 things about messaging to your students. In our classes, we set the tone about learning. Meaning, if when your students say things like, I hate word problems, and I don't like math, and I can't do word problems, if you are coming back to them and saying, I know, they suck, don't they? I really wish we didn't have to do them, but we do. That is well-intentioned, right? That is well-intentioned, but it is not helpful to their productive thinking about mathematics, their feeling of whether they belong in mathematics, and whether they can do mathematics, because they might already have a preconceived notion about what they can and can't do in math. So when we start, when we are thinking about the messaging in our classroom, we need to have a growth mindset, and we need to encourage a growth mindset within our students within mathematics. But we also need to ask the students to work together with word problems specifically, so that they can start practicing growth mindset, so that they can start practicing asset-based language, and we can support them in doing so. By connecting math word problems to numeracy and ultimately the GED test, because if you did not know this, GED or HiSET, if you did not know this, they are both heavy on the word problems, which is why we teach them, right? They are very, and some students say, why? Why do they have to do it in a word problem? You should answer that question, which is, and one part of the answer to that is, this is the application of the mathematics we are learning. And in your life, as being a literate and numerate person, we often have to tackle problems in multiple forms, in multiple modalities, and we are using numbers or numeracy concepts and our reading skills. So that's why. An asset-based perspective can go a long way with our adult learners, as they bring a wealth of experiences to the classroom. My favorite classroom that I have, and I don't like to say favorite, but I'll be honest, my favorite classroom is always the one where there is a wide range of ages in the classroom. I find that some of my students who are not in their very young years have a lot of experiences that they can share with others, and a lot of this growth mindset or asset-based perspective that they can help. And we need to take advantage of that as teachers and allow them to be the facilitators of some of the numeracy happening in the classroom. Also, we have the benefit of teaching adults. And I say that meaningfully because adults have the capability to have abstract thought. Their brains, for the most part, are developed, right? They have the ability to think about things abstractly and then think about things quantitatively. Children don't all the time, depending on the age of the children, right? And sometimes they have lots of factors, even in middle school and high school, such as hormones, that are impacting their ability to really think abstractly and get beyond that dysregulation of their bodies. And so when we're teaching adults, we really do have this benefit of their experiences and their background knowledge impacting our math classrooms. Just one second. My Zoom block is blocking the arrows that I need to advance my slide. Okay. Here we go. I just did. I got it now. Asset-based language should become a norm for you and your students in your classroom. Here are some prompts as a facilitator of learning that you can use while tackling word problems with your students. These are not just for the teacher and facilitator. Students should start using them as well. These came directly from Caitlin Tucker, and she has her own website about asset-based feedback rubrics specific for the math classroom. These are things about, like, tell me about your thinking. What patterns do you notice? You are building on what you already know about. Tell me more about your partner's reasoning or strategy. Okay. I see some of you writing, so I'm just going to give you a second. I don't want to rip it away from you. I'm I'm going to give you a few others that are a bit longer. The ones on the previous slide are things I think maybe students would come around to using. These might be some that you put in your back pocket to be using more often, which is things like, you're starting to build a strategy. Let's build on that by taking a look at what you already have. Do you see how that's asset-based? You have something. Let's build on that, as opposed to, you know what, that's not right, start over. Okay? You have work here. I want to point out this piece of it. Let's build on this piece, and then continuing the conversation. Something like, you remembered the first step. Now let's revisit which formula fits this problem. Or, I notice you're using addition to find groups. Let's build on that strategy. That's when I think of when students are using repeated addition versus multiplication in my low-level classes. Is I see that you're using addition to find groups, and that's great because that shows me you have these concepts. Let's build on that strategy to get them to the next step. So that's one example of something specific for a math classroom. We're going to do an activity in a moment where you are going to work through a task, and I'm going to ask you to use asset-based language after you've had some time with your table mates or in the chat to support your table mates. In the room, there are some cards that have asset-based language or prompting on them. You don't have to have them right in front of you now, but if you are feeling like, I don't know how to start with this, you can use the support of the cards in front of you. Before we get too far along in that, I want to give the task. So this is the task. It's also on the note sheet if you have the note sheet in the room. But it should be on the screen for those of you that are virtual. And you're going to have some time in the beginning to work on this on your own. Here, there is an image of kind of what looks like a house, right? There's a triangle and then a square, or I should even say it's a square because I don't know that. This is not to scale. And then there are boxes that signify different measurements of this diagram. Then there is a triangle that says equals, and there's boxes for 2 numbers or digits. Then there's a rectangle that says area with an equals for 2 more digits. The task is to, using the digits 0 through 9, at most once. So you may not repeat using a digit. You may not use 2 more than once in this task. Place a digit in each box to make the statement true. So you can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Only one digit can go in a box. Okay? I'd like you to work through this a little bit on your own in front of you. We are going to get a chance to talk about it with our peers. So work through this. Feel free to use any of the materials in the center of the table if that helps you. Same goes for those online. So I'm going to look at my watch, give you a few minutes to work independently, and I'm going to try real hard to be quiet, which is not my strength. Those of you online, there was a question in the group. The The box to place a number that's inside the triangle refers to the height of the triangle. All right, when you're ready, you can start to talk to the people at your table about your work. Your work does not have to be complete to engage in the classroom. You do not have an answer. You do not have to have an answer to engage with your peers. All right, put a period on the end of your sentence or idea. Anita, would you mind running the mic for me? Would anyone like to share something they heard or something they said that was using asset-based language? Please say that out loud. Yeah, please say that in the mic.
I wasn't doing a good job at all. I was like, that should be a 6. So
So
probably do with my students.
okay. Thank you for saying that. Thank you for saying, you know what, this is where I am at, and this is what I am doing. How could we change no, this is a 6 to be asset based?
What if I said, what if this wasn't a 6? That's not any better.
You know, I can't fault you for that one. Does anyone have a different idea about how you could change no, that's not a 6 as the teacher? So our students are going to say things like that. Don't get me wrong. How could we address that as a teacher? Instead of saying no, that one's not a 6, how could we say something to get them?
You could just question and say something like, how did you get 6 here? And see if they can reason their way to recognize that that's not correct there.
Yeah. How did you get 6 here? Or tell me about your thinking for this box. Okay? Do you see how we changed it from, no, that's wrong, right? Which she didn't say, no, that's wrong. But that's what students hear, right? No, that's not a 6, and because you have the authority as the instructor, right? I am wrong, and therefore I'm not finding success with this type of problem. Okay. This is called an open middle problem. The man who did that video in the very beginning of our session, Robert Kaplinsky, this is his website, openmiddle.com. That is where this problem comes from, free accessible resources. Today we worked on a pretty high level open middle, not the highest, but this is a pretty high level. I purposely do that for a group of math educators in the room, and some of you I realize are new to math, and that's okay. But I purposely do that because I want you to productively struggle. However, I want you to also know that on the Open Middle website, he has these types of problems from kindergarten to 12th grade. So if you're thinking, gosh, my students would just shut down if I put this in front of them, you can scaffold this. You can teach them how to do open middle type problems where they are responsible for the thinking, and with a lower level problem, right? They have things like box plus box equals box, right? The other idea about open middle problems is that there's almost always more than one answer. Did anyone come to an answer? Okay, Janiyah has 2. Janiyah, would you like to share one?
So the one that I just did is we were trying to work in 8, because my first one, 8 was in the area, but it wasn't in one of the dimensions. So we were trying to work in 8. I don't remember why.
I think 1, 2, 3, 4 didn't work.
Okay, yeah, because one of the ones we tried before didn't work. So I was just substituting various numbers in, and I moved the 8 from the base of the rectangle to the height, and then it worked. So I was able to find a height of 8 and a base of 4, and then the height of the triangle was 5, which gave me an area of 10 for the triangle and 32 for the rectangle.
Excellent. Nicely done. In the interest of time, I'll share with you the one that comes the most commonly, but that does not mean that Janiyah's is not correct. But the base of the rectangle being 8, the height 7, the area 56, the height of the triangle being 3, and therefore the area being 12. Okay? If you want to know more of the answers, the other part of this is at openmiddle.com. It's almost the answers, because sometimes there can be a lot of answers because it's such an open problem. There are kind of the crowdsourced, right? Like people who love this kind of thing, they'll go on and go, I found 12 answers to this problem, and they will list them all. This type of problem is not necessarily about finding an answer and what if it's correct. This type of problem is what we just did at the table in a very short snippet. This would take, the first time you do an open middle problem with your students, there might be a little bit more hesitation, there might be a little pushback, there might be, it might take you a little bit more time because you're trying to facilitate this type of conversation, but the more you do them, the more your students get comfortable with them, and the more your students start to get comfortable with you and others asking them about their thinking. All right. Okay. Has anyone seen this problem before? Raise your hand. There's about 8, 7, 8. Okay. This comes from the GED 10-question sample test item online. This is a series of problems, actually. There's 3 that go along with this same topic. I want you to take a look at the question on the right-hand side this time. Do you notice anything that is similar or different? Do you notice anything that's similar to what we just did with open middle problems? They can only be used one time? This is a very simple similarity. They have to drag and drop the numbers into the box. Guys, that's what I'm talking about here. Like, here are my finite numbers that I can use that I have to then plug into the equation. Are you seeing where I'm going with this? In the open middle problem, we had you looking for being able to put the numbers in the boxes, right? But this time, we're having a bank of numbers that they're allowed to then put into the equation to make it work. The concept is the same, right? Or I shouldn't say the concept. The method of how we do this math is the same, right? So we're already kind of exposing our students to some of the things they're going to have to do on the GED or the high set. I know on the GED they have drag and drop questions. I'm not as familiar enough with the high set to know if they have drag and drop questions. But so if your students are thinking, this is not going to be on the test, how many of you get that answer? Is this going to be on the test? I don't think this is going to be on the test. It isn't always about the mathematics specifically that you're doing that day that's going to be on the test. It's about the problem solving that you're doing in the class that you're going to use on the test. Every time my students ask me that question, they stop asking me eventually because they say, is this going to be on the test? Is this going to be on the test? And I say, yes. And then they say, is the color blue going to be on the test? Yes. Like, it is always yes, because number one, if students do not feel like it is in the interest of their goal, they're going to back out, right? Number two, every single thing in my classroom is intentionally preparing them for what they're going to see in the future, which includes the GED test or the high set test. Yes, ma'am.
It seems to me that the activity that we just did is actually more rigorous than that. Because on this one, we could guess and check. If you're giving us the options, you put parameters around it. So it almost feels like you're going deeper than what they need for the GED test because there's fewer parameters.
So in the room, one of the participants mentioned that the open middle problem seemed to be almost deeper than the problem I'm sharing on the screen because you have the option of kind of plugging in the numbers and working with them. And in this case, there's only 8 that you get to work with, and they're already kind of predetermined for you. I agree. Thank you for that observation. That's very good. This question also, notice how much reading is here. Right? We've got a small paragraph at the top, a table, so understanding that, a small paragraph at the bottom. Then on the right, this is just the prompt to answer the question. The information on the left gives you all the context behind the problem. So this is where we're going to start moving into not just asset-based language and how to use that, but also how do we help students see that there's a lot of text here you have to make sense of before you're even thinking about dragging and dropping and moving those things where they belong. This is another GED sample question that has to do with inequalities. You've probably seen it. This one is about planning a meeting for the company. When we use strategies like keywords or highlight all the numbers, sometimes that doesn't serve us or your students for every type of problem they're going to encounter. And this is a good example of that. You can go ahead and highlight the numbers that are in the problem. You can look for keywords. But ultimately, because the question is that you're being asked to find the inequality that's going to match this, that's more about you understanding what's going on in the problem than it is about you being able to compute an answer, right? So keywords limit thinking. And I don't mean that they're useless. I mean that they serve us in a very low level of mathematics when we are trying to help students think about words like together or total, right? But together and total can be applicable for a lot of different operations. And the word together or total can also, you can have a multi-step problem that involves several operations. So if we start off by telling our students every time you see the word total, it's an addition problem, you are not serving them as they get higher up in different levels of mathematics. You are not helping them get beyond the level of math they are in right now. Sometimes there isn't a keyword. You have to actually make sense of the problem. And most GED or high-set math problems require more than one step. So guiding them just to, if you see this word, do this, just does not serve them for the types of problems they're going to see on the test. This comes from Light and Salt Learning. I know that Katie Redmond is here and presenting. I don't know if she did it already or not, but this is from her website directly. Skills needed to pass the math GED or high-set test. A reading NRS level of 4 or above, usually on the progress tests. I know there's exceptions. Sense making, critical thinking, and time management. Some of the concepts that are critical for your students to have knowledge about are algebra, slope and lines, formula-based geometry, data analysis, and interpreting word problems. And as my friend back there in the blue said, we need to be digging deep, not wide, with our students, because that's where they develop the conceptual understanding to apply to various topics and all of these topics within the GED and high-set test. We're going to start with the 3 reads protocol. If you have the piece of paper in front of you, this is the back of the piece of paper. The 3 reads protocol gives us a scaffold or a strategy to use with students to help them think about how to solve word problems. This is not a strategy that I tell my GED level ready to test students that they must do for every word problem on the GED test. They don't have time to do this during the test. This is a scaffold to get them to start making it a habit of the mind. What do I do when I reach that test and I don't know how to start? Okay? Many of our students, the GED or high-set math test is the last one they take. It's the one they're the most anxious about, the one that is the most failed or not passed. And that's common knowledge. You can ask GED here in the exhibit hall if you need to get a second source. It's not that it is the hardest necessarily, but it is something that students generally have more gaps in. And so we have to build those gaps up. One of the ways that I do this is by using the 3 reads protocol in my classroom. Any level of my mathematics classroom. And there's also, if you teach more than math, there is also a 3 reads protocol for language arts. So you can take this idea and connect it very easily to language arts. The first part of this is to read in for context. What is the situation about? What's the story of the problem? Can you describe the situation in a sentence? I have some sentence starters here for you because sometimes people get a little caught up in wanting to solve. And so I want you to be thinking very clearly about this, which is, I think this problem is about. This problem is about blah. Or in this story, I think that this is happening. So this is the problem. It's on the back of your sheet. I'm also going to read it aloud because that is part of the 3 reads protocol, is to have it read aloud. It is not only being read by the individual. An aquarium manager drew a blueprint for a cylindrical fish tank. The tank has a vertical tube in the middle in which visitors can stand and view the fish. The best average density for the species of fish that will go in the tank is 16 fish per 100 gallons of water. This provides enough room for the fish to swim while making sure there are plenty of fish for people to see. The aquarium has 275 fish available to put in the tank. Then there is also a diagram that shows the cylinder with another cylinder in the middle of it, and there are some measurements such as the main cylinder, or the cylinders are 4 feet tall. The radius of the inner cylinder is 2 feet, and the width of the outer cylinder is 3 feet. Now, going back to these sentence starters, I'd like you to fill in those blanks. I think this problem is about what? And there's a space on your sheet if you want to do it right there in step 1. I think this problem is about this. I think, or in this story, I think this is happening. So that's all I want you to do right now, is write on your paper what you think the situation, what's going on in this problem. I'm going to have you run the mic in just a second. For my virtual participants, feel free to go ahead and put that in the chat, and we will announce your thinkings. And then in the room, is there anyone that would like to share what they wrote or what they think this problem is about, or what the story is happening in this problem? Don't make Anita read off your paper. She'll do it. No, I'm kidding.
Do you want me to
Please.
do all 3?
I'm sorry? No, just the first.
Just first, I think it's about the volume of an aquarium.
You think it's about the volume of an aquarium. Okay.
I think it's about how many fish the aquarium will contain.
Okay. Thank you.
I think it's about how much water can that tank hold.
I think it's about how much water can the tank hold. All right, we've got lots of math people in here. So generally, you thought, oh, this is a math. This is going to be about volume. This is going to be about fish. This is going to be about proportions, right? Now let me tell you what some of my students sometimes say when I give them this type of problem. They say things like, this is about trying to build an aquarium for the fish. This is about how big the donut is. Okay? Do you see the, now I point that out not because I want to minimize your answers, right? But rather set the expectation for, if you do a problem like this, what you should expect initially. Because when you do these open thinking problems, you're going to get a variety of answers. I got what I think of as perfect student answers in my PD, right? I hope that some of you had things like how big the aquarium is and how many fish will fit. Okay? Now, the second step. Yes, Janaya?
You know, I did put the ideal number of fish for the aquarium, but I also thought about that 2-foot wide section in the middle and thought this is not very big girl friendly.
Janaya thought that the center of the The center of the aquarium was not very big girl friendly. I did have a student once say, why is there a cylinder in the middle? Like, and who's going to fit in it? And I also had a student that said, how are they going to get in the cylinder? Is anyone from Georgia?
It's only 4 feet. Can't you just step into it?
At the Georgia, has anyone been to the Atlanta Aquarium? My absolute favorite aquarium visit is in Georgia, in Atlanta. You have to go. In the penguin exhibit, you can kind of crawl under the exhibit and go into this plexiglass cylinder, and literally your head is on the level of the penguins. And they can be like literally this close to your head. I think it's meant for children. I did it anyway. It's amazing. Yes, ma'am.
There's a place, I think it's called the Bass Pro Shop near Branson, Missouri, and they have some tanks like that. And yes, I climbed in there.
Yeah, that's right. I just remember there was like lots of little kids, and I was like, am I supposed to be in here? All right, so let's move on to step 2 of this 3 reads protocol. Is there anyone, Anita, would you mind reading it, if you don't mind, the problem for us, just so there's a different voice?
Be glad to.
Anita's going to read it this time to just give you an idea.
An aquarium manager drew a blueprint for a cylindrical fish tank. The tank has a vertical tube in the middle in which visitors can stand and view the fish. The best average density for the species of fish that will go in the tank is 16 fish per 100 gallons of water. This provides enough room for the fish to swim while making sure there are plenty of fish for people to see. The aquarium has 275 fish available to put in the tank.
So now my question is, what can be counted or measured? What quantities do you see in the problem? Quantities are different than numbers. Quantities have value with them, or units. Quantities are numbers with their units. So in step 2 of in your sheet there, it should say something similar. Identify the quantities in the problem. What can be counted or measured in this problem? Go ahead and take a few, like maybe 30, 40 seconds to write those down or think about those things. All right. Would you like to share what you wrote in that for just number 2? So the second step of what we're doing today.
What can be counted is the volume of the space, the gallons of water,
Okay.
and the fish.
Okay. Thank you.
I think I do the same way, but I word it differently. What can be counted as the ratio of fish to gallons.
What can be counted as the ratio of fish to gallons? Okay, rate of fish to gallons. Did anyone write 4 feet tall? 4 feet tall? Yeah, I did when I did this. Dimensions of the cylinder? Sure. Again, my students tend to look right for the numbers, and sometimes they forget about the quantity piece, and they go 3, 2, 4, 100, 16, and 275. And then I say, and then we have a conversation about quantities and what quantities mean. And then, but often here, there's 16 fish per 100 gallons of water. There's 275 total fish. If you want to put the labels on it, you could say that the inner radius of the radius of the inner cylinder is 2 feet, the height of the cylinder is 4 feet, and so on and so forth. After we're done with step 2, we read it again we're not going to do this because in the interest of time, but we would read it aloud again. You can have students choral read it. You can have students do it on their own at this point. The idea is you're reading it more than once. Don't we tell our students to do that? We need to practice that so that they get in the, and some of you are, I can see it on your faces. You're like, Amber, get to the point. I want to know the question. This is a little painstaking for you, but I guarantee you in your classroom, this is creating lots of sense making and thinking time for your students. The last step is to read to plan a solution. What are you trying to figure out? How can you solve the problem? How can you answer the question? This is when you reveal the actual prompt for the answer. So notice this is a little bit of a slow reveal, right? We have a question without, we have a task without the question. That is purposeful because we want to think about and help our students see the first steps to a math problem without answering, because the answering is not the first step. So this is the question. It says, is this the right number of fish for the tank? If not, how many fish should be removed or added? Explain your reasoning. Now, we don't have time for you to figure this out, so if you want the question, you better write it down because it's not on your piece of paper. But if you want to go and figure it out later on your own time. Can you tell me something that you think this 3 reads protocol, how do you see this helping your students?
My students want to go right to the answer.
Yeah.
But I keep telling them, you're answering a question, but not the question.
Thank you. This whole protocol is intended to help slow down that process of add up all the numbers and that's my answer, right? Some of my students legit do that. Here are all the quantities, I'm just going to add them all up and that's got to be the answer. This also helps you make sense of the problem before you even get to the question. You can do this with any problem. It can be even, you take away the answers on a multiple choice problem, you take out the question, and we just focus on the first 2 parts of it. In our adult numeracy network, we have an instructional routines club that meets about every other month or so. We're just getting it off the ground. But this is an instructional routine within that. And if you want to be a part of more of these types of things, or you want to be a part of practicing these types of things, you can join the Adult Numeracy Network, but also you can just join the club and see what it's about before you even commit to a membership with the ANN. We'd love to have you. This type of work is really important for our students, but really important for us because many of us did not grow up with these types of problems in our math education. And so we are learning it sometimes right with our students on how to best reach and teach all of our learners. I encourage you to experience and stay in this room and be as well, because that's the adult numeracy strand. But of course, I know you have other priorities in your conference. Please make sure that you rate this session within the Hoover app, as well as all of your sessions in your COABE experience. And if you have any questions, I am always available and willing to meet virtually or in whatever way possible to talk about any of this. Thank you very much.